Okay, so the properties we're talking about. The first property, the first two properties, sum difference and constant. You guys have been using that one since the first time we did integrals. Sum and difference, constant multiple. Okay? Sum and difference, if you're adding, you can separate. Constant multiple, if it's a constant being multiplied, you can move it to the front. Okay? The three that we have not covered, which the ones we're going to cover mainly today, mostly today, are reverse. With reverse. So the lower bound always has to be at the bottom, and the upper bound always has to be at the top, or else you can't do this process. We can't find the area under the curve, because when we find area under the curve, we always go from left to right. So if I have a graph, so for example, draw a picture. A to B. And let's say this is the function here. And we need to find area under the curve. We always have to go from left to right, from the lower to the upper. That's the way we always have to do it. Sometimes what they'll do is they'll reverse the bounds. We can't go from right to left. I can't go from here to here and find area. So to do that, you reverse what's called reverse the interval. You can reverse them, you can switch spots with them, but you have to put a negative sign in front. That's how to do it. Okay? So if it's asking you to go in the wrong direction, you can switch them. You just have to put a negative sign in front. Okay? Because they'll ask you, they'll say, this is 2 and this is 5. And then they'll say 5, 2. That's going in the wrong direction. That's like reading a book right to left. That's like saying, read a book from right to left. You can't do it. It doesn't make any sense, right? Same thing in math. We can't read a graph from right to left. It just doesn't work, right? So if we want to switch them, it's okay. You can switch the bounds, but you just have to put a negative sign in front. Okay, to switch them, you just have to put a negative sign in front. Okay? Zero length. Zero length is pretty, I don't want to say pretty obvious, but it's common sense. If you go from the same bound to the same bound, you don't go any distance. I go from A to A. There's no area because it's just a line you created, and a line has no area. Okay? So if you go from the same spot to the same spot, there's no area. Okay? Adding intervals. This is another big one. Adding intervals. So if we go from A to C, you can break that down if there's a spot in the middle. So instead of going all the way from A to C, you go from A to B and B to C. Okay? So it's cutting it up. It's cutting up the whole area. So let's say I had, let me put another point out here. What this says is the area of the blue and the orange is equal to the area of the blue plus the area of the orange, right? You can cut it up like that, okay? All it's saying is the sum is equal to its parts, okay? You can cut it up like that, okay? So like I said, those are the three that are the new ones that we haven't talked about. 1 and 2, you guys have taught. We've had notes about those. We've had assignments about those, all that good stuff. Okay. So example number 1. They give us, these are the given. There is a function that the area under the curve from 2 to 6 is 10. And another function where the area under the curve from 2 to 6 is negative 2. Find the following. Okay, find the following. So there's a function here where area under the curve from 2 to 6 is 10. And there's another function where area under the curve from the same area, covering the same plot, same area, is -2. So they want us to find the area under the curve for both, adding. Well, that's just property number 1, or the first property, sum and difference. If you're adding, you can give them their own. They have the same bounds. As long as they have the same bounds, you can give them their own. Okay? And we know that the area from 2 to 6 for f of x is 10. And the area from 2 to 6 for g of x is -2. So the area combined is +8. Okay? Next one. Now we're subtracting. Same bounds, but now we're subtracting. So again, you can reverse it. Or sorry, not reverse it, but split it up. Area from 2 to 6 of g of x is -2. Area from 2 to 6 of f of x is 10. -2 minus 10 is -12. The area, the difference in area is -12. Okay. Using the same givens, number 3. From 2 to 6, 3 times f of x. Well, it's 3 times f of x. So you can move the 3 to the front and just find the area. The area of f of x from 2 to 6 is 10. So you're just tripling the area. Okay, all right, do letter D. Do letter D right now. Wait, we did letter D. Letter D is the same as letter B, isn't it? Yep, it looks the same. Okay. We won't do it again if we already did it. All right, so go to the next page. Go to the next page. So we have some givens. From 0 to 5 for f, the area is 10. From 5 to 7 for the same function is +3. So they want us to find the area from 0 to 7. How do I do this? Because none of these, I don't have any 0 to 7s. None of these are 0 to 7. So how do I do this? Yeah, they give me from 0 to 5, and then they pick it up from 5 to 7. So really, I do have it, right? Let me draw a little picture. So from 0 to 5, I don't know what the function looks like. I'll just use my imagination. They're saying that area under the curve is 10. And then with the same function to 7, this is not to scale, this is 3. And then they ask you, what is the area from 0 to 7? You actually do have it. It's the total area. 10 plus 3 is 13. Okay. Letter B, from 5 to 0. From 5 to 0. Oh, I have it here, don't I? Isn't that 10? Yeah. Can't read a book from right to left. Can't do math from right to left. We can't go from right to left. If you believe that, try reading a book from right to left. You can't do it. The English language, we can't read from right to left. So we have to flip the bounds. So we can do that. You can flip the bounds, 0 on bottom, 5 on top. You just have to put a negative in front, or -1 in front. So this guy is 10 times the negative in front. The area is -10. The lower bound always has to be on bottom. The upper bound always has to be on top. If it's not, flip them. Just put a negative in front. Okay. All right, so do C and D now. Same example, do letters C and D right now. So C is from 5 to 5. You're not covering any area. You're not going anywhere. You're going from 5 to 5. So if you're not covering any area, you have 0 area. Okay? 0 to 5. Move the 3 in the front. And then that's equal to 10 times the 3 is 30. Okay. All right, so now let's look at a graph. The regions A, B, C, and D are bounded by the graph of F, and the x-axis. So the area of each is enclosed are labeled in the figures. So they've given us area under the curve for each of these. They've given us area under the curve. Each of these is labeled. So like this is 9. This is 15. This is also 15. And this is 5. Anyone see a problem with that? Yeah. 15 and 5 on underneath, that's the area. But remember, we have to give them negatives. They should be -5. The area is 15. But because it's under the x-axis, it needs to be negative. So they just gave us the areas. They didn't take into account that it's under the x-axis. Okay, so we have to find the value of -6 to 3, 5 f of x dx. -6 to 3. So I'm going to go from blue dot to blue dot, going from left to right, so I don't have to flip the bounds. Move the 5 to the front. Okay. So from -6 to 3, I'm going to add up this guy, and this guy from blue dot to blue dot. So -15 to 9 to -5. So it's -20 plus 9, -11. -5. Okay. Okay. Number 4. I'm not sure if we're going to do all of this. A lot of it's repeating itself. This lesson doesn't take very long. because it's just the properties. Okay. I just put a bunch of different problems on here. Like we'll definitely do 4 and 5, but the next page, maybe we'll do a few of those, but I don't really need you to do all of them because again, we've done all of them. It's just kind of repeating itself. Okay. Properties isn't a very long lesson. Okay. So they give us new bounds or they give us a new area. Okay. So area under the curve here is -9. Here is -8. Above, we got +9, and we got +4. Okay? So we have to find the area under the curve from -6 to 4. Which property are we going to use to solve this one? We've actually used this property. You've actually seen this problem. Not this problem exactly, but this type of problem before. We've done this before in this class. Which property we're going to use? Look at the properties that we've used before. Sum and difference. If you go back to our, I'm not sure if it was the last set of notes or the ones before that, we had problems like this. Sum and difference, right? We got a minus. F of x minus 1. Yeah, so the sum and difference says separate them. F of x gets their own minus, same bounds. We don't change the bounds. Okay. So this guy, we can look at the graph. So area under the curve from -6, -6 is here, to +4. So we go from left to right. So it's going to cover that area, and that area. So -9 plus +9 is 0, plus -8 is just -8. How do I find that guy? So what? It's not going to be 1. We've actually done this type of problem. I'll show you where we have, just to show you. I'll show you we've done this problem before. Last set of notes, yep. Look at that one here. I'm going to look at this one here. It's the same thing, right? It's the same exact thing, except bounds are different, and this is 1 instead of 3, but it's the same problem, right? So if that's the function, what this means is from -6 to +4, the function is 1. And we need to find area under that curve. It's a rectangle. It's got a height of 1, got a base of 10, 10 times 1, +10. Done. Okay. All right. All right, let's see. Number 5. So number 5 is the same type of problem. They just don't give you a picture. It's the same type of problem that we just did. There's just no picture. But there's nothing saying that you can't draw a picture, right? If you need to see it visually, go for it, okay? So for example, let's see. Since these are our notes, I'm going to draw a picture. So it looks like this whole thing goes from -6 to +3. So from -6 to +3. And it says the area of that altogether is -2. So that means there must be something at least underneath the x-axis. Because to have a negative area, you have to go underneath the x-axis. I don't know what that looks like. I don't know. This is just what I think it looks like. So when I add up those two areas, I get -2. But then when I go from -3, I can already tell my picture's wrong. Let me draw something more to scale. Because from -3 to +3, it's got a positive. And then from -6, it's got a negative. So that means above the x-axis, and then I go below the x-axis probably here. Again, not perfect, but it's the best that I can do with what I got. Okay. Again, you don't have to draw a picture. It's not required, but since it's the notes, I just drew a picture. So from -3 to +3, the area is 5. From -6 to +3, the area is -2. What is the area from -6 to -3, f of x minus 2? Well, again, which property am I going to use to solve that guy? Same one I just used, right? Sum and difference. So let me do that. Let me split it up. -6 to -3 f of x minus -6 to -3, 2. Okay. That guy there. So from -6 to -3. Do I have that? No, I don't have that, right? -6 to -3 means from here to here. Can I figure that out? Yeah, I can figure that out. From -3 to +3 is 5. This area here is 5. The whole thing is -2. The whole thing is -2. I need to find the piece. The whole thing is negative 2. From negative 3 to positive 3 is positive 5. So how do I figure out what the missing part is? How do I figure out this part? So add negative 2. Here's the thing, though. I don't really want negative 2, though. I don't want this piece. Wait, do I want this piece? That might work, but this is the whole. This is the piece. If I add them together, will that give me the missing piece? I think so. Right? See, what I was thinking was take the whole. So whole minus piece equals missing piece. But since they're negatives, this might work too. So the whole is negative 2. The piece that we know is negative 2 or is positive 5, right? Negative 7. Let's see if that works. Don't just take my word for it. Let's kind of see if it makes sense. Okay, so if the whole is negative 2, when I add up the two pieces, I should get negative 2, right? Okay, so the first piece is 5. The second piece is negative 7. If I add up those two pieces, do I get negative 2? Yeah, so that's right. When I add up the two pieces, I should get the whole. Okay, we got that. Now this guy is going to be exactly like the one we did earlier. From negative 6 to positive 3, the function is 2. Makes a rectangle. It's to negative 3? Oh, sorry. Okay. So let me change this picture a little bit. Okay, so it's got a height of 2. It's got width of 3, so it's 6. So we get negative 13. Negative 13. Okay, let me give you, instead of doing the last problems, because the last problems are just more of what we've done before, let me give you another one like that. That's a good practice problem. So in lieu of the other problems, let me give you let me find another practice problem that's similar to that one we just did. Okay, so first thing, split it up. From 3 to 8. Well, we don't go from 3 to 8. We go from 1 to 8. So the whole thing is 1 to 8. The whole is 2. We need to add up the two pieces. Well, one of the pieces we don't know. 3 to 8, we don't know. I don't know what 3 to 8 is. But I know what from 1 to 3 is. So it would be negative, right? What is it going to, what plus 3 equals 2? Negative 1. So that means the area from 3 to 8 has to be -1 because when I add them up, they have to equal 2 because 2 is the whole. And then this guy would be a rectangle, or it's actually be a square, 5 by 5 square. 5 height, 5 width. Done. Okay. All right. So the last page we're not going to do, don't worry about it. It's just more. If you want to do practice on your own, I'll post the answers